So this one is classified paper, block 1, page 8. The question is related to topic 1.2, which is about motion. Define acceleration. How we define the term acceleration? The acceleration is refers to increase in, because if you remember the last pop quiz, it was defined deceleration, but here is an acceleration. So it is an increase in speed or a velocity in unit time. Like every second, how much there's an increase in the velocity, that is refers to acceleration. The next part is figure 1.1 shows a speed time graph, accesses from the graph of motion of a car. The car starts from rest, and for time 0 to 15 seconds, the car has a constant acceleration to a speed of 28 meter per second. So the car reaches a 28 meter per second when the time is 15. And then from 15 seconds to 32 seconds, the car has a constant speed of 28. It does not change the speed. And for the last part, 32 seconds, the car has a deceleration, like the car slow down or decelerate with a deceleration of 2 meter per second square, and it stops. We have to complete the graph to show the motion, draw a graph. So how it can be done? As you can see on x-axis, 10 boxes equals to 10. So each box is representing 1. And on y-axis, 10 boxes equals to 10. So each is representing 1. So from 0 to 15 seconds, so where we get 15? This is 11, 12, 13, 14, and 15. So this will be 15. It has a speed of 28. So this will be 25, 6, 7, and 8. So this is 28. So when the time is 15, the speed is 28. So we have this point. But as you can see, from 0 to 15 seconds, it has a constant acceleration. In a speed time graph, how we represent constant acceleration? So it will be a straight line passing through the origin until it meet a point where acceleration, like it reaches speed of 28. Then from 15 seconds to 32 seconds, it has a constant speed. Like it does not change the speed. So from 15 to 32, so this is 32. So from 15 to 32, the speed of a car does not change. It has a constant speed of 28. So we draw a line, like we mark a point from 32 to where the speed is 28. And because the speed does not change, so how we represent a constant speed in a speed time graph? We represent a horizontal by the horizontal line. Then what happened? The car from 32 seconds, it has a deceleration of 2 meter per second square until it comes to rest or it has stopped. So if it comes to rest or the car has stopped, it means the final speed should be 0. But how we know, like how much time it will take for a final speed to be 0? So we have the formula that acceleration is a change in the velocity divided by time. Acceleration or deceleration. How much is a deceleration? That's equal to 2. What is the change in the velocity? Originally, it has a velocity or a speed of 28, and then it comes to rest, so the final is 0. So what is the change here? The change is 28. And divided by time, we need the time, so we cross multiply. So the time will be equals to 28 divided by 2, that's equal to 14 seconds. So it will take 14 seconds from 32 to 14, like 32 plus 14 makes 46. So this will be 1, 2, 3, 4, 5, and 6. So that will be 46. So we draw a line from 28 till 0 at time equals to 46, sorry, not 42, 46, because like because like 10 boxes equals to 1, so each is represent 10 boxes equals to 10, so each is representing 1, so it's 41, 2, 3, 4, 5, and 6. So 12 plus 14 makes 46. So when the time is 46, the speed of the car or will be 0. So that's how we will have a speed time graph for an object which is first having a constant acceleration, then moves with a constant speed, then it has a constant deceleration. Why we do this working? Because we want to work out the time it takes to get the speed or to reach a speed 0. Is it clear, this one?
Yes, sir, clear.
Okay. Then the next part is for a time 15 to 32, the path of the car is a part of a circle, like it's moving in a circular path or a curved path. When for this motion, state the direction of a resultant force. Whenever object move in a circular path or a curved path, what is the direction of the resultant force? The resultant force is always directed towards the center. So what is the direction of the resultant force? That is towards the center of the curved path or a circular path. What happened to the velocity? Because if an object is moving in a circular path, it changes the direction. The speed does not change, but the direction of the motion continuously changes. So as a result, when the direction of the motion is changing, what happened to the velocity? The velocity of this car will also change. Like if I say an object is moving at a speed of 10 meter per second, changes the direction. Is there a change in velocity? Yes, there is a change in velocity because velocity is a vector quantity and the vector quantities depends on the direction of the motion as well. If the direction of the motion change, the velocity will also change. So this was page 8.